Welcome to part 1 of the module on Android support for programming concurrent and network software. Android will figure prominently in later parts of the course, and so this module will give you some background to make sense of how we use it later. This particular part of the module will present an overview of the Android software architecture. Android provides a layered software stack that's designed for mobile applications and various reusable services. As you can imagine, it uses heavily the layers pattern that we talked about in earlier sections of this part as well. Android starts with the lowest layer of its software architecture with a variant of the Linux operating system that's been optimized to conserve power and ensure high-speed communication between processes. On top of the Linux foundations, then comes an optimized Java virtual machine called Dalvik, a subset of Java libraries that run on top of Dalvik, a set of native C and C++ libraries, and a hardware abstraction layer. On top of those layers is a group of middleware layers. These layers provide things relating to user interface interactions, multimedia frameworks, cameras, telephony services, and a variety of other kinds of application frameworks that are used by people who build applications, as well as ways to distribute apps from an app store. And then finally, shipping with Android are a common set of apps themselves. If you take a look at the URL at the bottom of this slide, you'll find more information about the contents of the Android software stack. What we're going to do now is walk a little bit more deeply into each of the layers and talk about some of the key interesting things, especially as they pertain to concurrent and network software. Linux and the Linux portion of Android is what you'd expect based on what we've covered in earlier modules in this section. It provides support for managing memory, processes, threads. It has a network stack both for internet communication as well as communication between processes on the same machine. It has a framework for device drivers, and it also manages permissions and security. There's also a set of enhancements that have been added to the core Linux distribution to do things that are more Android-centric and enhance the capabilities of mobile apps. And these include the binder high-performance inter-process communication drivers, shared memory, which are used by the binder, among other things, sophisticated power management to try to avoid running down the power battery on the devices, as well as other services that are used to manage life cycles, things like a low memory killer that's used to clean up apps and services when the memory on the phone starts to run low. The URL here gives you more information about the variant of Linux that's used on Android. On top of Linux is something called the hardware abstraction layer, which is kind of a funny name because an operating system like Linux itself is a hardware abstraction layer. So to some extent, the hardware abstraction layer in Android is a set of user-level C and C++ libraries that separate the upper layer parts of Android middleware and apps from the Linux kernel itself. There's a couple motivations for having a user-level hardware abstraction layer in Android. Some technical, some non-technical. Some of the technical reasons for having a user space HAL, or hardware abstraction layer, are because some of the capabilities that Android needs to provide to the upper layer middleware and applications really aren't broadly supported in a standard way inside the Linux kernel device drivers, things like the radio interface layer that's part of Android. Another less technical reason is that if you ship drivers with Linux, then they fall under the GNU public license, which means the source code must be disseminated along with the binaries. And not all device manufacturers using Android felt comfortable giving away all of their intellectual property. So some parts of Android in the hardware abstraction layer are not commonly available in open source form. If you take a look at this URL, you'll find a very nice discussion providing more details about the hardware abstraction layer on Android, how it works, how to interact with it, how to program things at this level. The next set of layers are called native C and C++ libraries. These are, as you can imagine, typically optimized for performance. The idea of writing things at this layer are to make sure that you minimize latency, maximize throughput, try to conserve resources as much as possible, things like memory and so on. Some things that are provided here, of course, would be the standard C library, which you would use if you were writing native services and native system services for Android. Also available are some multimedia frameworks for audio-video streaming, where performance is very important. There's an open source WebKit browser environment, a browser engine that's widely used on many mobile platforms for the browser interfaces and interactions. Something called SQLite, which is a relational database engine that's used to store information persistently in Android. And also the secure socket layer, SSL, which is used to ensure integrity and confidentiality when you do various kinds of e-commerce interactions from Android to the cloud devices out there. If you take a look at the URL at the bottom of this slide, it provides some additional information on how to program with the Android Native Development Kit, or NDK, which is useful when you program at this level. Another set of capabilities is the Android Runtime. These provide support services for executing applications and frameworks on Android. The key capability here is something called the Dalvik virtual machine. Applications on Android are typically written in Java, but they don't run in a standard Java virtual machine. Instead, they execute on Dalvik, which is a variant of the Java virtual machine that uses a register model as opposed to a stack-based model. And there's also a set of application utilities that can be used to take existing Java class libraries and compile them into the Dalvik executable format, or the DEX, which is actually what runs on the Dalvik virtual machine. Application components typically run in their own processes inside their own unique Dalvik VM instance. You can take a look at this URL for some more information about Dalvik. Also important at this layer are a set of core Java libraries. Most importantly for our purposes, these include various Java networking libraries and various Java concurrency libraries. Not all parts of what you'd expect to find in a standard Java release are part of Android. And if you take a look at this URL, it explains some of the differences between what's in Android and what would come in a typical Java release that you would run off or outside the Android platform. The next layer up is where we start getting out of the systems realm of Android and closer to the application layer. These are the so-called application frameworks, and they provide services that are essential to the Android platform to do its job as a mobile device platform for running mobile applications and reusable services. Some of the interesting app frameworks here include things like the Window Manager, which manages top-level window look and feel type of interactions, the Package Manager, which is used to download apps from app stores and be able to install them into the phone itself, the Telephony Manager, which manages the state of telephony services and other messaging services like MMS or SMS, as well as things like the Location Manager, which is used to keep track of the phone's location, which you can imagine would be very important for certain kinds of mobile applications that we become reliant upon these days, like maps and so on. There's a nice description at this URL that provides additional info about the Android application frameworks. And then finally, with the open source release of Android, there also come a number of useful common applications, things that you'd expect to find on a smartphone today. Browser, email, contacts, calendars, camera, SMS, MMS, media players, and of course the phone itself. Most, or if not all, of these applications are actually written in Java, although some parts of the Android frameworks make heavy use of Java Native Interface calls, or JNI calls, down to C and C++ for performance reasons. What we're going to do next is talk about the four main types of Android components that are used to develop apps and services running in the Android environment. These typically reside in the application frameworks layer and the applications themselves. We'll be using a running example throughout the next several slides that's based on a programming assignment I give in one of the courses I teach here at Vanderbilt University on systems programming for the Android environment. And if you take a look at this URL, you can find out more information about the class and the assignment and so on. This particular assignment starts out by using an activity, which is one of the core Android components. An activity represents a single screen with a user interface. So when you interact with your phone and you see a screen up there, That's typically implemented by an activity. In this particular example, we have an activity that prompts the user to enter in a URL for an image they would like to have downloaded and displayed on the phone. The activity itself can be started by creating something called an intent object, which is a data structure that keeps track of actions and data and categories and so on, and then passing it to a method called start activity that goes ahead and launches that activity using something called the Activity Manager service to do its work under the hood, which is all part of something called the intents framework. You can associate certain extra parameters with an intent that can be used to start a service and provide information to it initially. Most applications in Android have multiple activities they use to give you different look and feel screens for different kinds of things. Here's a URL that you can take a look at to learn more about activities in Android. The next component we'll talk about is a service. Unlike an activity, a service doesn't interact directly with the user. Instead, it runs in the background, and it's typically used to perform longer running operations, such as being able to interact with remote services, perhaps in the network in a cloud. The particular way we're going to use a service for our example application is to take the URL that was captured by the activity and then start a thread or threads to download the contents of that URL, the image, from a remote server. There's several different ways to start services in Android. One way is a so-called started service. These are usually done to perform a single operation and often don't return a result directly back to the activity or other part of the code that started them. As with activities, you can pass parameters as extras in the intent that's used to start the service. The start service function is used to start a service this way. The second type of service is something called a bound service, which, surprise, surprise, is launched by calling bind service. And this offers a client-server interface that allows different components, say activities or other services, to interact with the service over a longer conversation as opposed to a one-shot launch. Most commonly, those interactions between services or between activities and services are done using something called the Android Interface Definition Language, AIDL, and something called the Binder Remote Procedure Call, or RPC mechanism. And we'll talk more about those shortly. Here's a URL where you can learn more about how services work in Android. The next component that's commonly used in Android is something called a content provider, which is used to manage shared data that multiple applications may use in order to persist various kinds of information, be able to interact with each other through shared persistent storage, and so on. For our example application, we will use a content provider and the file system to actually store the downloaded images and also keep track of metadata associated with those images, things like the time they were downloaded, their size, and the type of an image, and so on and so forth. Data is typically stored within an SQLite database, which makes it persistent. You can store in other places too. You can store in files and so on, but many, many content providers, the predominant set of content providers in Android, typically use SQLite as their backing store. And SQLite provides with all kinds of operations to query, insert, delete, and so on. You don't typically access a content provider directly, but instead you access it through something called a content resolver. And there's various ways to get access to the content providers through the content resolvers in Android. Here's a URL that gives you a bit more information about content providers and content resolvers. The fourth and final common component in Android is something called a broadcast receiver, which is a component that responds to system-wide intent broadcast announcements. For example, we could have our activity register a broadcast receiver, so after the image has been downloaded and stored in the file system and the content provider and the SQLite database, the activity can be notified and the information can then be extracted from the file system and displayed in the activity's user interface so the user can see what the image looks like. The neat thing about the way in which broadcast receivers work in Android is you can actually support fairly complex querying and intent filtering on these intents that are used to deliver information in various ways to the broadcast receivers. And you can have these things either sent to particular components using explicit intents, or you can let the Android intents framework figure out where to deliver the intent using a so-called implicit intent, which uses some of the information that's part of the intent to do the filtering. You can take a look here and learn more about broadcast receivers. So to summarize this section for part one, Android defines a layered software stack for mobile devices. Take a look here for more information about these layers and how Android works. It's a great presentation from about 4 years ago, 5 years ago, that gives you great degree of insight as to how Android is architected. Android also provides a set of framework components that applications can use to do their work, activities, services, content providers, and broadcast receivers. And these typically run in the context of a Dalvik virtual machine, inside a Linux process, of course, and so on. And here's a good place to look for more information about these components. And another key thing which makes Android especially relevant for this course is that the source code for most of it, with small exceptions for some of the hardware abstraction layer topics we talked about earlier, almost all of Android is available in open source format. And here's a link where you can go to download the source of different versions of Android. So I strongly encourage you to read these links, download the source code, and we'll talk a lot more later about how these different layers and these different components can be used to build interesting concurrent and networked applications in Android.